Hello everyone, welcome to YourPedia Education. Today we are here at IIT Ropar. So I got an opportunity to interact with Dr. Ashwini. So hello professors.
Hello.
So thank you for taking out the time to meet with us today. It's an honor to have you here with us.
Thank you.
So could you please start by introducing yourself, brief about your academic journey and your professional journey, please?
Yes. So, hi everyone. I am Dr. Ashwini Sharma, working as assistant professor in the Department of Electrical Engineering at IIT Ropar, and I did my PhD before joining IIT Ropar from Technical University of Madrid in Spain in the domain of antenna engineering. And before that, I did my master's from Polytechnical University of Madrid in the domain of communication system and engineering. And prior to that, I did my BTech from LNM IIT Jaipur. And after PhD, I have joined the IIT Ropar as assistant professor, and then we have established here antenna and microwave research lab. Mostly, I'm teaching the undergraduate student the course of electromagnetic engineering, and at the UG, the PG, and post PhD level, we are handling the antenna engineering problems, and then the research is related to the antenna and microwave engineering.
So that's quite impressive, Dr. Ashwini. So as you told, you joined here as an assistant professor. So this antenna and microwave lab was established or installed under your supervision, or it was already there before you joining?
Yeah, so once I have joined, I just got the one empty space of 30 cross 30 feet square.
Right.
There was nothing in the lab. Then slowly, gradually, we have built the system there. We have installed the furniture for the students. Then we have installed the all antenna fabrication and the characterization facility. Right, that I will be explaining later while discussing.
Yeah, so Dr. Ashwini, here I want to discuss very practical point of view, right? See, mechanical engineer we use in daily life. Electronics engineering we are using in professional, personal, domestic life. So when it comes to RF and microwave, although it's a part of communication system, but what is your take on this? How student can realize this? How they can basically conceptualize the things that what is RF and microwave? What is brief about this?
Right. So when we talk about, for example, communicating, right from one point in the space to the other point in the space, we have several means of communications, right? So we can, in general, use wired communications, right? Obviously, voice is also there when we speak. Then that is also like a kind of wireless communication. But when you talk about like how the machine will be communicating with the other machine, with giving a luxury of mobility. For example, if the two machines are fixed. One is at particular location, other is at another location. These fixed location machines can be connected with the wired connections. But the moment you allow mobility into the scenario, like one node is actually moving, transmitter is moving, or the receiver is moving. In that case, this wired kind of communication or a transfer of information is not feasible solution, right? Or even if you try to apply the wire, there is a mobility concern. Like the mobility is not that huge. The user is not able to, walk here and there, usually more frequently. So what I'm trying to say here is there is a need for the wireless communication between the two nodes in general, and this wireless communication through the means of RF and microwave is actually being done for a quite long time, and now the time is for the next generation of wireless communication system, where you see every node is actually going to communicate or to be interacting with the internet. So that facility, if you provide with the wired kind of communication, it is really very difficult establishing so many of connections. But the wireless communication actually establishes multiple sort of connection between the nodes. Right. So this RF and microwave actually is sort of, you can say right now, is commercially viable option to connect these multiple devices. And the antenna being the end entity of these communication link, you can say, is very crucial entity. So our lab is actually focusing in designing the novel cost-effective antenna types to establish these wireless connections.
Great. So can you tell me in microwave and research, this antenna and microwave research lab, what all activities are executed? What are the key research area which you focus under your research group?
Right. So the moment we have established this lab, we have started with the small IoT and 5G kind of antennas, starting from RFID antennas. Like RFID antennas are not just for the you can say RFID tag for
Tags and all
the
that.
tags, which you already see it is already commercialized and working nicely.
True, true.
But other than that, also when you talk about tracking and tracing of different objects, like in the farming, dairy, and then other you see manufacturing and any other like logistics, these sort of application, they always require tracking and tracing application,
Right.
where this tags has to be pasted on different objects, different platforms. For example, the tags can be pasted on glass,
Right.
like on your vehicle it is mostly pasted on glass,
True.
but many times it has to be pasted on the metal object.
Oh.
So the moment you paste it, it doesn't work because of the platform. So we initially focused upon like how to design these RFID tags to make them platform independent, so that they are able to work on, let's say, water platform,
Right.
or you see a metal platform or wooden platform
Right.
seamlessly with a very high range kind of a system.
True.
And then now we are actually switched our focus towards like developing efficient and product for IoT and 5G application.
Okay.
Because usually what happens is the research area, they are driven by the whatever the current funded projects which are running in the lab, in our lab.
Right.
So starting from the lab last 4 years, there was a project of 3 years duration funded by DST,
Okay.
and that was about the design and development of the cost-effective antenna types for IoT and 5G.
Okay.
So regarding that, we have developed a lot of antennas for the application of wireless power and data transmission.
So, Dr. Ashwini, here I want to interrupt you. This question is from the
Right.
student point of view.
Right.
See, we talk about as you're talking about the IoT, 5G, soon it will be 6G, 7G, XYZ, right? So, do you believe that, don't you think as a researcher, how a researcher cope up with the transition of technology? What is important, to learn the route or to upgrade with the technology, or both are required basically?
Yeah, so the most important is the route is obviously is very, very important. The moment you actually able to understand the route,
Right.
or you are very much comfortable in that route set of skills,
Right.
then it is easy to adapt the new technology. The
Right.
moment if you are not comfortable in the route itself, you are unable to adapt the new technology or unable to understand.
Right.
Even if you try to understand, it takes a huge time, right?
Right.
So most important obviously is the route. However, we cannot actually spend a huge time in understanding that route.
Right.
So whatever is the requirement at that moment of time, the moment you are solving the problem, that route can be understood that moment, and then you can apply those information to the you can say advanced level, right?
True.
So both are important obviously, but the route obviously is the first thing that has to be done, and then understanding the next level, or you can say upcoming technology, is also important to be in the line with the current technology, right?
Okay, so right now this antenna and microwave labs, which all students are performing their experimentation here, be it undergrads, postgrads, or PhD, or it's all kind of student?
Right. So we have a mix of students at different levels.
Right.
So starting from the highest level, we have PhD students. They are working on the different research problems,
Right.
obviously aligned with the funded projects, but they are also doing their independent,
Right.
sort of picking up independent research. For example, some of them are working in wireless power and data transmission,
Okay.
how to design efficient antenna system. Other is working on RF energy harvesting.
Right.
For example, like you will be having a lot of sensor nodes in the next generation of systems. There, how to power these sensor nodes, because putting battery in each and every node is very tedious job,
Right.
because that require recharging, replacement, and other.
So you mean to
maintenance
say
costs.
self-power kind of?
Self-powered kind of, like how these IoT nodes can be self-sustained.
Right.
That sort of research is being performed by one of the PhD fellow, is recently graduated.
Right.
Other set of research is in the near field charging domain, where how to charge the different electronic devices like a smartphone, and then you have tablets, and then other gadgets, wearables, for example, hearing aids, smart sensors, how to wirelessly charge these.
True.
So actually, we are concentrating on designing the novel platforms
Okay.
for efficiently charging solutions for these devices. Like for example, drone is also coming into the picture nowadays.
Right.
Is being envisioned as an integral part of the 6G next generation communication, where drone will be highly utilized in all the domain, right? So we are focusing now, focusing also in how to go for the self recharging of these drones, like whatever the platform on which this drone is going to sit, how to recharge. So that sort of study is also being done by the PhD
So how
scholar.
basically a PhD scholar or research scholar, because you are being a research scholar yourself and now you are executing those things as a supervisor.
Right.
So how difficult is it to maintain that synchronism between, working on the current technology and at the same time anticipating what's coming in the future?
True. So actually, I will divide into 3 parts. First of all, like upbringing their skills, because the moment student is actually joining here,
Right.
in IIT Ropar, they may be having very diverse background.
Right.
Some may be exposed to these root, or you can say basics, and some may not. So what we have is the initially 1 year, we train them upbringing their skills, giving them time to learn, and then obviously through the courses they have to take initial first year, we raise their skill. That is the first set, so that they are feeling comfortable in understanding the concept in future. The second level is like whatever is currently we are doing, our current objective is they are actually start doing that for a couple of years, like 1 or 2 years. Whatever the current existing you can say vision of the lab is there, they are aligned with that, so that they start learning how to advance into the new future technology. And then the last years, you can say a couple of years, they focus on whatever is coming into the future. For example, 6G or next generation technology, they actually try to adapt those those techniques, or they try to apply their developed techniques into those scenarios.
True.
So actually whatever work we are doing is mostly is use case scenario based.
Okay.
So we develop a technique, or you can say antenna prototypes for the use case specific.
Okay.
For example, one use case you may think of, let's say drone assisted communication.
Okay.
That is the current funded project by the DST in our lab, that talks about how to use the drone to actually communicate in, let's say, areas where the mobile is not working.
Right.
Let's say some disaster happened into certain remote area.
True.
There these you can say dedicated communication system is actually broken down.
Right.
So there you can use the drone to communicate with the several nodes.
Right.
But that drone antenna specifically required some very, you can say, judicious control, or you can say design.
Selective control.
Yeah, selective control and these sort of. So how to devise this drone to ground station communication, how to devise this drone to drone communication, or drone to other sensor nodes, these sort of stuff is going on. So actually students are adapting those use cases and applying their current knowledge into those. So this is how this PhD level people are working. So now we have second layer is the masters.
Right.
So as a master's program, we don't have an exclusive RF and microwave master program. So whatever the students are coming, they have to get involved into the MTech in specialization for SPCOM.
Signal processing and
communication. Okay. So under this communication group, our group is there, Antenna and Microwave Research Lab, and there we perform all these tasks. So that is for the master level. So for 1 year of master degree, they do all the coursework, and then within that coursework, some couple of electives are floated by me. I float mostly like modern antennas, how to design from theory to practice. These elective courses I'm floating. Then I'm floating basics of RF communication engineering. There they learn about what is the basics of designing these antenna, how to understand more electromagnetics into detail. Then RF system for communication. These are the elective courses which are being floated for these students to understand. And then in the second year they join for the project. So they elect our lab for the project implementation. We assign some problem, they solve it for 1 year, and then they are able to produce nice results. And at the BTech level, obviously they are coming BTech in electrical engineering. So they are in third year, I'm teaching electromagnetics course. And then following semester to that, we are conducting electromagnetics lab. There they learn about hardware stuff, hardware experimentation, and then how to simulate these electromagnetic structures. Basics that are covered. And the fourth level is the internships. So we are also hosting a couple of internships every year, where the students from international abroad also they are joining, from India various institutions they are joining, and then couple of months they are actually working on a given very confined problem, and they are able to complete it within the time limit.
So Dr. Ashwini, here I want to ask you one question related to internship, right? So if somebody tomorrow wants to connect you for internship, obviously there might be some university procedure or institution procedure, right? So you need to fill some application and this kind of thing. But as a faculty, how somebody can approach you if he is totally aligning with your research group activities? There might be a student who already have done some preliminary research work. They want to get your supervision. How they can connect with you?
Right. So there are a couple of ways students are already connecting. Obviously, the one way is directly writing the email, but how they are able to join, right? So one is institute funded internship that is already open for the institute level. So they can actually apply through there and then they can come. Second is international internship opportunities, that is also institute level. Then the third one is project specific. For example, whatever the current projects which are running, they have the notion of internship students, hiring manpower in terms of internship students. So students can actually connect with me over the email. I consider their CV and then I shortlist and I ask them to join in the summer.
True.
So that is actually funded also, like some funds are given to the students.
Okay.
And the other one is like if some student can handle without funding, for example, if they are interested, very highly interested in learning,
True.
and they don't seek any funding opportunity here, then they can obviously write through email and we can consider their application. We have already considered application for the remote working of the students.
Okay.
Like some of the students, they don't want to visit also, like
Right.
because of the far distance.
True.
So they are actually remotely working. So
Okay.
those sort of scenarios are always
That's a great
Yeah.
thing at IIT Ropar.
right.
Second thing, I'm talking from the student perspective, career point of view, right? As you told that, many research being done here related to 5G antenna, IoT antenna. See, what I see in Indian institutions, there are a lot of research being done, published. But I believe, I might be wrong, we are not in the position to convert them into industry or product.
Right.
So basically, what kind of assistance IIT Ropar is providing here? Is there any kind of, linkage between the academic and industry where student can showcase his research, whatever being done by him?
Right. So this is a very nice question. So what I can see, IIT Ropar is providing platforms, right, to convert your whatever the research you have performed, right, to the product level, right?
Right.
So the one way is like whatever the students are working or learning in masters. For example, there is a joint thesis program,
Right.
where the students are getting engaged in the joint internship, you can say, with the industry.
Right.
So here one supervisor is from IIT Ropar, other supervisor is from industry,
Yes.
and student is mostly working in the industry itself.
Right.
So that is actually how we are connecting with the industry.
You mean
learning
to
from
say,
there.
if I'm not wrong, sorry to
Right.
interrupt, if somebody is going for internship,
Right.
so he can choose there what topic he want to work for thesis.
Right.
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 Okay.
So what happens is it is a year-long internship.
Okay.
In the MTech program, we have 2 years program. 1 year they do coursework.
Okay.
Other year they do the thesis work, right?
Okay.
Project work. So that project can be entirely done in the industry.
Right.
That option is there.
Okay.
So that gives us the luxury to convert our, like say,
Right.
whatever we have developed and giving to the industry for their deployment.
Right.
That is the one thing.
Right.
Another thing is, let's say I have some idea and that I think that it can be commercialized easily.
Right.
Then we have a technology incubation center.
Okay.
We can always take their help.
Okay.
We can actually have a startup here.
Right.
Even faculty can start.
Right.
A lot of students are engaged there.
Right.
And I have seen like our senior PhD fellows here, even before graduating, they have started the company.
Right.
They are able to finish the PhD also, and now they are successfully running.
Oh.
They have come up with the products also. So
Right.
we actually at IIT Ropar having all the facility to convert our research ideas to the product level. So that luxury is always there.
That's truly amazing.
Right.
So now what I see many times, students are worried about placement when especially they are joining masters and PhD. So how do you consider it? If somebody is coming into field of communication, so what kind of career option student can seek ahead? What is your perspective on this?
Right. So what I can see here, like for the BTech student, there is not a big problem.
Right.
Being an IIT, they are mostly
Yeah.
placed with the handsome salaries and all. But what perception for the PG and post PhD students are there? So I would say that whatever the students are being trained here in our lab, after graduating, they are doing wonderful jobs.
Right.
Like students did done masters here, they are placed in very highly reputed universities,
Right.
doing their PG further like PhD level studies,
Right.
in US and UK. And then the students which are graduating with a PhD, they are doing postdocs, getting a nice offers
Right.
for a handsome package also,
Right.
right? Also, like students are getting jobs in the industry also, because there is a huge demand for the RF and antenna engineering
Right.
nowadays. I have been fortunate enough to interact with couple of industries when I was visiting some conferences in international level. There I found that these industries, they are struggling with good antenna engineers.
Okay.
They are always actually seeking for some positions filled by the good RF and antenna engineers. So what I can see as far as the opportunity is concerned, there is a plenty of opportunities in the RF and antenna domain. The important thing is the student must be very much clear
Right. Right.
about the concepts here,
Right.
must be very much clear about the life goal. For example, he wants to do the hardcore technical stuff throughout the life. then only he can decide like to go into the industry and all. About the academics, obviously after masters, they can join the PhD program in foreign university or Indian university. Mostly they are getting offers, very nice offers.
Right.
And then they are also joining like industries and other, you can say, institution in India like DRDO, ISRO. All these things are obviously hiring RF and antenna engineers always.
Okay, that's great, sir. That's great. So, sir, see, when we see about the RF and microwave, right? Let us suppose, everybody don't have that luxury that he is graduating from IIT in this highly densely populated country, right? And they don't have the supervisor like you, who have a, depth of knowledge. So, through this video, what information you would like to convey to our user if they want to excel in the field of RF and microwave? So what they should start learning as a subject fundamental or as a tools and software and technology which may help them in the long run?
Right. So as far as the antenna and microwave engineering is concerned, first of all, the student must be very much clear about fundamentals of electromagnetics.
Right.
So that actually can be done through like learning the electromagnetic engineering, where like lots of books are also there, like DM Pozar is
So
there.
I believe NPTEL is one of the handful resources for that,
true.
right?
So online also there is, because nowadays students, they are more comfortable in learning through online portals. We also actually refer our students to go for NPTEL.
So what is your take on NPTEL? How do you consider it? Is it a handful resource to go through for?
It is very much helpful, because there are eminent professors who are actually teaching,
Right.
and there are video lectures which are available, and they are nicely teaching them. So I also remember my days that I also was using these NPTEL video lectures to understand, having the deep knowledge or theory background of the electromagnetics engineering. Right. Then after that, a student needs to learn about the antenna engineering.
Right.
So one is electromagnetics engineering, that is a very basic.
That is a very basic foundation.
Basic foundation they have to gather, and then they have to learn about antenna engineering. They can pick up some very reference book, like Balanis is a very nice book for the antenna engineering. So they can learn about it. There are online resources also available. After that, they must be now starting learning about the simulation softwares. Right. So in the simulation, they can use the MATLAB, obviously, which is nothing but the calculator, mathematical calculator. Whatever analytical formulations they have learned in the books, they can actually try to implement using MATLAB and see how it is functioning. Right. And the next level is the electromagnetic simulators. Right. So we have in our lab, we have HFSS, NC's HFSS and CST design studios, where they can actually try to build these systems, whatever they are going to design, like microstrip based antennas and these all, they can actually design in these studios, and they can simulate, and they can visualize the results. So one skill set is there, simulation based. And then after simulation, obviously they need to go for fabrication. They can actually contact any PCB prototyping machine, industry or anyone to fabricate their antenna, and then they can try to measure. Right. For the experimentation, they need a skill set to measure using VNA, that is called Vector Network Analyzer. In our field, there they can measure the S parameters for the system they are developing, 1 port, 2 port, and the other ports. And then for the real measurement, they can use the antenna characterization facility like anechoic chamber and other test bands. So these skill sets they require.
So as you mentioned in the introduction, you have completed your master's and PhD from abroad. So how was your experience? I'm not saying that abroad is good, India is bad, but as an individual, how was your experience? How you were able to differentiate it from the Indian education system?
Right. So the one point here, what I find like different in abroad and India is, in India we are actually very much hardworking. Whatever task is given to us, let's say for 15 days, we are able to complete in 5 days. The reason being, we are able to work 24/7. Especially, but what I have seen outside, they only work 9 to 5. And then their outcome is also accordingly, is visible, right? So that is the major difference. So what I found in Indian education system, this system actually makes us really very hardworking. And we never say like, this is the problem, we are now able to escape and we are not able to solve. If we are not able to solve, we are trying to solve it.
We are not able to understand, or we are not able to interpret the signals of mind, basically, because we have the brain that to have the capability and capacity,
So because maybe I don't know, because of the population or maybe what is the reason, but there are students not getting enough opportunity to actually prove their potential.
Right.
But there, because of they have a lot of resources, population is less.
Right.
Even they may be struggling with the admissions, for example, not filling up all the seats. But here is the scenario is opposite. So what I believe, because of that, many students having potentials are not maybe getting nice opportunity. So that is the difference actually in the Indian and foreign.
Sir, you have done your MS from where?
Yeah, it's Polytechnic University of Madrid.
So you did directly after bachelor, or you take some industrial experience?
So my program was integrated MS and PhD.
Okay.
So I went for the PhD admission. Okay. In between, they have sent me for the master's program.
Okay.
Right.
So there were requirement of GRE or IELTS, or it was totally waive off?
Right. So mostly in the Europe, when you go like this European country, except the UK, you do not have any GRE or TOEFL requirement as such. Other countries, they always ask these GRE and TOEFL requirements. So as far, because the thing is, in European country, they are not English speaking countries, so they are not asking that, for example. So after BTech, there are options directly to go for the masters or even go for the PhD without giving this GRE or other TOEFL examination. However, they may consider, you see your CV, for example, have you done any good research, or have you done any work related to whatever the project they are floating? Right. So these all things they actually see, and then they hire.
True. Great, sir. So sir, any final piece of advice you want to share, and any message you want to give our viewers who are willing to join IIT Ropar and who wish to venture into the field of research, please?
Right. So I just at the end, I just want to say that our lab is established 4 years ago only, and then it was then we actually arranged for all the instrumentations and all these things initial years, but still we are able to perform nice job here, and our potential is actually is proved by, you can say, our outcome in terms of publications and our students which are placed at very nice positions. And then I also invite all students. We are always looking for bright, hard-working students who are very much interested in RF and antenna engineering. They can come and contribute and align their vision with the vision of our lab, right? That is to excel in the field of antenna and microwave engineering.
So thank you so much, Dr. Ashwini, for your time, and your insights have been truly highlighting, and I'm sure they will inspire many of the researchers out there. Thanks a lot.
Thank you so much.